Okay, welcome back. This is a video over Unit 2, Section 5. We're going to be talking about sloped intercept form, okay? One of my favorite topics in math. We use it all the time. You are learning it currently in Math 8, but you will use it in Algebra 1. You will use it in geometry. You'll use it in Algebra 2. You'll use it in pre-calc. You'll use it in college algebra. You'll use it in calculus. And then you'll keep using it throughout your math career. So, talking about slope and slope-intercept form of a line, you will always come back to it. So best learn it now and make it easy for yourself. So what we want to do is we want to be able to analyze a graph to determine the slope and the y-intercept. We want to be able to graph a linear function using the slope and y-intercept. And we want to be able to write a linear equation in slope-intercept form given the slope and y-intercept. So the first thing we want to talk about, we keep using this word, y-intercept, okay? Now, the y-intercept, okay, by definition is right here. The y-intercept is the point on a graph at which the graph crosses the y-axis. So here is your y-axis, okay? And what we have here is we have the scenario, okay? So Tara starts with $15 in her bank account, and she plans to save $5 per week. So we can model this concept using this graph, and we talk about time in weeks, that's our x. Okay, and then total amount saved. And what we do is we can show that initially, all right, Tara has $15 in her bank account, okay? And every week, she puts in $5 more, okay? And we show that by the slope here, okay? So every week, so $5, okay, every 1 week. All right, same thing. So 5 up 5 over 1, up 5 over 1. Now, I know that the graph may not look like it's up 5 over 1, but we have to think about the scale that we have over here on the y-axis. We're going up by 5s, and then 2 blocks here represents 1, okay? So that's why it looks like that. You know, otherwise, if it was a 1 by 1, graph, it would be going up a lot faster, okay? So what we can do, first of all, is we can identify our slope as $5 per week, okay? And we would just write that as 5, okay? Slope is equal to 5, okay? But it represents $5 a week. Now, our y-intercept, and I often call the y-intercept B, is equal to what we started with, where it crosses the y-axis, which is $15, okay? So what we can do is we can write an equation like this that says y equals 5x plus 15 to represent this situation. Now we'll get into how I obtain that information on the next page, but let's go ahead and let's kind of talk about our y-intercept again. Okay, so notice, and let's do something here. Okay, if I draw a graph over here, all right, and here's my y-axis. If I were to plot a point anywhere along my y-axis, all right, and let's just do this. This is going to be the point 0, 3, 0, 2, 0, 1. Let's call this 0, negative 1. Let's call this 0, negative 2, 0, negative 3. What I notice about these is that anytime that my x, or that my graph, that I have a point on the y-axis, my x value is equal to 0 on the y-axis. Okay, that's important, okay? So we can identify our intercepts strictly based off of points, okay? And oftentimes what we'll do is we'll just write like b equals a number, but we want to understand that these are points on a graph, okay? So remember, x is equal to 0 for those points. Now, non-y-intercepts, well, the x value is not 0, okay? It's something other than 0, and that would be some other point on the graph, okay? All right, so let's talk more about slope-intercept form, okay? And what we do is we let m represents the slope, okay? That's important, all right? And what we do, okay, by looking at these graphs, we can identify that slope, okay? And so remember that m, slope, is equal to rise over run, okay? And we can calculate that slope because the slope can be positive, the slope can be negative, the slope can have a 0 slope, or it can be undefined, okay? So we have those options. Now, b all right? B represents your y-intercept, okay? And so what we can do is we can write this equation in slope-intercept form, and that is going to be y equals mx plus b. So what we can do is, given a graph, we can identify the slope, okay, and that's the steepness, rise over run. We can also identify the y-intercept, which is where it crosses the y-axis, and then we can automatically generate an equation, okay? So pretty cool. All right, so let's take a look at this problem down here. Okay, Jasper has $20 in his bank account. He deposits $8 per week, okay? So here's what I've got. My initial value, and my initial value is the same thing as my y-intercept. So initial value, same thing as your y-intercept, is $20 in the bank, okay? And then the rate of change, which is also my slope, okay, is going to be $8, and I know this, $8 per week, because it tells me, okay, it gives me this rate, $8 per week. The word per is going to indicate rate of change, okay? So what I know, I have my initial value, my y-intercept is 20, so b is equal to 20, and I know that my rate of change, or my slope, is equal to 8. So what I can do is then just immediately write an equation and say y is equal to 8x plus 20, and boom, we're done. That's it. That's all I'm doing. So if we understand the concept of a slope and we understand the concept of a y-intercept, okay, then we can write this equation, okay? Now, over here it says, it asks us this question: how much money will be in the account after 25 weeks? So what we know is that x is weeks, okay, and y is the total amount in the bank account from the situation. So what I'm going to do is plug in 25 for x. So I'm going to get y equals 8 times 25 and then plus 20. So 8 times 25 is going to give us 200. So $200 and then plus another $20. So the amount of money in the account after 25 weeks is $220, okay? And that's what we've got, all right? So let's take a look at the next page, look at more on writing these equations. Okay, so on the next page, we are identifying the slope and a y-intercept from an equation, okay? So we have this general form, y equals mx plus b, where the number that's in front of the x represents the slope, and b represents the y-intercept. So if I'm given an equation like this, okay, what we want to be able to do is to identify what the slope is and what the y-intercept is, okay? And so just by looking at this, okay, y equals -1/2 x minus 8, you know, this is in the form y equals mx plus b, okay? This is my formula for slope-intercept form. So the slope of my line is the number that's in front of the x, and this would be -1/2. And then my y-intercept is the constant on the other side of that equation, and that's going to be -8, okay? And so that's what we have, is this problem as such, okay? So now, all right, let's go the other way, all right? So we can also write a linear equation if we know what the slope and the y-intercept is, okay? So write an equation with the following characteristics: slope of 3 and a y-intercept of -1. So all I'm going to do is take these numbers and I'm going to substitute them into my formula, and I'm just going to write y equals 3x plus -1. Or we could write it like this: y equals 3x minus 1, however you want to do it, okay? Now I can also do this from a graph, okay? I can identify my y-intercept, so b, and let's use blue for b, and my y-intercept is right here. Okay, I know that this point is the point 0, -3. And then, so that's the first thing, b is equal to -3. Then what I can do is I can figure out the slope. I can make my stair step, and I got to look at my scale, but what I know is that I rise up 2 and I run 1. Rise up 2, go up, run 1. So rise 2, run 1, 2 over 1. So my slope m is equal to 2 over 1, which is just equal to 2. Okay, so then I can write my equation in slope-intercept form, and I could write this as y equals 2x minus 3. And that's that. Okay. All right, the next thing I can do is I can just graph these equations, okay, which is pretty powerful. So here's what I know. All right, I want to graph this equation, negative 3/4 x plus 1. First things first, let's identify our types of slope. So types of slope. This will help us graph. We can either be positive slope, we can have a negative slope, we can have a zero slope, or we can have an undefined slope. So currently what we have is we have a negative slope, okay? So we want to determine the slope and the y-intercept. So first of all, I'm going to write out in this that m is equal to, and let's do this in red, m is equal to negative 3/4, and my y value, or my y-intercept, is positive 1. Okay, so that's first thing. First step is identify what those are. The second thing is we want to plot the y-intercept. Okay, this is our starting point. Starting point. All right, and so what I do is I plot this point right here. Okay, that's my starting point. Then what I want to do is I want to use my slope m to create more points, okay, a second point. And ideally, you only need one other point, but let's put a couple. So I'm going to start here at positive 1. My rise over run is 3 over 4. Now, because I have a negative slope, I'm going to be going in this direction. So what I need to do is I need to go down 3. So 1, 2, 3 over 1, 2, 3, 4. And I'm going to plot a point on that graph. Okay. I can go the other way too. And I could say, I could start at 1 and go up 1, 2, 3 and go over 1, 2, 3, 4 and plot a point there, okay? And then what I'd want to do is I'd want to connect these with a line, okay? And that's my equation, okay? So pretty easy. So remember, okay, your y-intercept, okay? That's first, okay? And then the second thing you want to do is use your slope to calculate, you know, we go down 3 over 4, we go up 3 to the left 4. Kind of depends on how you want to look at it. Doesn't matter, but that's the idea. So that's all I got for this. All right, hopefully this makes sense. Hopefully this is like a breath of fresh air and you're like, oh my gosh, I know what I'm doing. Okay, if not, come talk to me. I believe in you. All right, see you, bye.